was asking.
Okay, so you said you try to do it by table. First of all, hello everyone. This is I'm starting to record. This is lecture number 9, I believe, and we're answering the question, which I'm going to spotlight me, and then I'm going to share my screen. So we're answering this question here. It says use table A to find the value z of a standard normal variable that satisfies each of the following conditions. So the first one is we want the point such that the proportion of observations less than it are 0.3. So if I load up table A, and I want the proportion less than it to be 0.3, I just look for 0.3 in my table. And 0.3 is right between those two numbers. Do you agree? Do you agree?
Yes.
0.2981 to 0.3015. So one of those numbers is negative 0.52, and the other one is negative 0.53. So 0.3 will be somewhere around negative 5.25, halfway in between. And when I look at the possible answers, there's negative 0.52 right there. Find the number z such that 35% of observations are greater than z. Well, if 35% are greater than z, then what percent is less than z?
$65.
65%, right? So I look for 0.65 in my table, which is between those two numbers. I don't know why it highlights like that, but whatever. You see what I'm saying between these two numbers? Yes, no, maybe so?
Yeah.
So it'll be about 0.3. Let's scroll down. So it's between 0.38 and 0.39. So, no, that's not what I want to do. Oh, done editing. I don't know what happened. Sorry, hit the wrong button. So this one should be about 0.38, 0.39, and there it is, 0.39. Does that make sense? Yes, no, maybe so?
Yes.
Yeah.
All right. And then you said number 8. What's your percentile? Reports on students' score, yada, 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 who cares? Okay, so here we go. Approximately normal, that's important. That's the mean, 35.8. That's a deviation, 2.1. That's for females. And for males, it's also normal, different mean, different deviation. Larry, a 60-year-old male, so we're going to want to use the male one, has an upper arm length of 37.2. So the question is, what percent is less than 37.2? That's, again, can't do that out of calculator or a computer of some kind. So I go on my calculator and I go to Normalcdf, and I want less than 37.2. So I'm gonna go from negative 999999999 up until 37.2 with a mean of 35.8 and a deviation of 2.1. So these are my numbers. Lower is negative infinity, just negative big number. Upper 3.75, mean 3.58, sigma 5.1. I hit, oh, was it 5.1? Sorry, 35. Oh, I did the wrong one. I did females. Sorry. Mean 39.1, deviation 2.3. I was looking at the wrong one, so I changed those numbers a little bit to match. And then I hit paste, and I get 0.204, roughly the 20th percentile. And when I look at my answers, sure enough, there it is, 20th percentile, 0.20. Someone's saying something. What are they saying? Where did you go on the calculator to get that? So hit second, hit the blue button, second, so you can go into blue mode. And then you'll see, I can't see backwards, and you'll see right here, distribution. in blue. So you hit this one. And that takes you to this page right there. And you're going to want to, oh, I hit the wrong one. Second VARs. I'll take you to this page right there. And then you go down to normal CDF. So you go down one to normal CDF. You'll never use normal PDF. You use either normal CDF or the inverse norm. In this case, normal CDF. You hit enter, and that takes you to that screen. And this is recording, so you can look at it later. Okay, questions on that question? Yes, no, maybe so?
Very good.
Okay, we're good. And then there was 10, someone said. 10. There are two major tests, ACT, SAT. Each one is normal with different means and different deviations. Reports on a student's score is usually given the percentile as well as the actual score. The percentile, you don't get that screen. What do you get? We're going back to the previous one for a second because she asked a question. What screen do you get?
I just get an error.
You have the same calculator as me?
I have the TI 83 plus.
Okay. Well, go back to the home screen. Go back to the regular one.
Okay.
So what do you hit first?
I go to second, and then I press the distributions, and then when I go to normal CDF and press enter, it just shows up normal CDF with the parentheses, and then when I press enter again, it says error syntax.
Wait. Why are you pressing enter again?
Because it just pops up normal CDF printed out on my screen with the parentheses. It doesn't have anything else with it.
You mean it looks like this?
Yeah, it looks like that, and then when I press enter again, it just pops up normal CDF with the parentheses on my screen. It doesn't pop up that right there.
Okay, so you have a different calculator than me, and I don't know your calculator, unfortunately. So what I would recommend doing is just do a Google search later for how to compute normals with a TI-83. And I'm sure someone in the history of time has made a YouTube video about it. But I don't know every calculator in existence, unfortunately. So I can't help you. I'm sorry. Okay.
Website that you showed us last time.
Yeah, you can use a website. Just you can use of course. You can just do what was it a Google calculator of some kind? What did I say? A normal distribution calculator or something?
Yeah, it should be like the first result.
You can use that. Perfectly fine. Okay, so.
Professor, I have a quick question.
Yes.
So for percentile, so when we're giving a percentile, like say we're asking, for instance, number 8, what percentile Larry is in based on his upper arm length and whatever. So let's say he's in the 20th percentile. Does that mean 20% of people scored low or have lower than him?
Lower.
Oh, okay.
Always lower. So the 99th percentile is very good because 99% were lower. You were really amazing. 99% were lower. That's a good thing, right? So percentile is always lower. Okay. Anyways, yeah, go ahead.
So for number 8, since he's in the 20% percentile, the approximately 80% people aren't his arm length?
No, that means 80% or more.
Yeah.
20% less, 80% more.
Okay. So in Larry's case, he's kind of on the bad end.
Yeah, he's kind of, he's one of those short people.
Okay.
Okay, or short arms, I guess. Whatever that means. Okay. So this is a similar question. Tanya scores a 1223. What's her percentile? In other words, what percent is less? So that's to go to the calculator. This is very similar to the other ones. I don't want to do every single one because it's a little redundant. I think now that we've done a few, hopefully the rest of them will make sense. If they still don't make sense, then feel free to come to my office hours or email me, and hopefully I'll answer all of them this weekend.
So for this question, would you put above, less, or between?
Which was 10 that we're on?
Yeah.
Well, her percentile, that's less. Her percentile, that's always less. Okay? In fact, it says the percentile is just the cumulative proportion stated as a percent. The percent of all scores that were lower than this one. Percentile. Okay? All right, so where are we? At this point, we have finished chapter 8, 5. What did we do last? I don't remember.
We finished chapter 4 and 5.
We finished chapter 4 and 5, but we have not yet done chapter 8, correct?
No.
Okay. So today, we're going to do chapter 8 because we're going a little bit out of order here, which is okay, as long as we get everything done. I'm going to load up an ebook that I have. If I find it. I don't have PowerPoints on this like I did for the other ones. So we will see now a different approach, and I guess you're going to be a good testing case for what's better, PowerPoints or non-PowerPoints. Just give me a second. I'm looking for this email that it's supposed to be. There it is. Okay. Okay. So ebook. Give me 1 second, guys. Hold on. Okay. Okay. Chapter 8. And speaking of chapter 8, we are going to have our first test next week. Isn't that exciting? So for this lecture, we're taking our own notes. Well, I'm going to do it on here, but yes, you're taking your own notes on this one. Yes. Is that what that means, Ani? Is it a shock? No, neither Tuesday or Thursday. I'm going to give it to you and let you do it over the weekend because I don't want to take class time, and this way you guys can just, do it when you have time. I don't care.
I'm sorry, Professor. So is the test going to be thing like the quiz?
The test will be, I have to figure out a way to get it on Canvas or to get it computerized because ideally it's graded immediately.
But do you want us to take it like over the weekend like we did the quiz, or do you want us to?
Yeah. So I'll give you like a window of like 72 hours to take it. That doesn't mean that you have 72 hours to take it. You'll probably only have 100 minutes like the class time, but you can start it whenever you want. It's just once you start it, you'll have 100 minutes to take it, something like that. That's the plan. So hopefully we can figure that out, and that'll be next weekend. So that way we don't have to waste class time because we're already behind. And I know you guys are all want to learn so much statistics that it will be a shame to take class time to do that. I know. You don't have to say anything. It's obvious. Okay, and the test will cover the first 5 chapters plus chapter 8. And chapter 8 is about producing data or sampling. How do we get our data? Well, let's talk about a subject that is very prevalent in modern day society, at least in America, and that is the up-and-coming election. Never in my life have I really seen a scenario where people are so invested in the coming election. Most people that I meet are very strongly on one side or the other. And there's not many people who are like, yeah, I don't care. Whatever happens. I don't know, whatever. And people are very strongly opinionated in this. So people like to know what the up-and-coming election results are going to be before the up-and-coming election. So how do we do that? Well, so-and-so poll says that, there's the chances of so-and-so winning are this percent and the so-and-so winning are this percent and so on. And how do they get that information? What they do is they ask people. Now, has any of you ever been asked in an official survey or poll what your opinion is on the up and coming election or who you're going to vote for? Someone actually might have said yes. Let's see. Oh, you have? Wow. Well, I never have. And most people I know never have. So how exactly, I guess is the question, how exactly can we be certain that the results of the poll taken are accurate if they didn't ask me and you and we both vote? So how can it be very accurate? And the answer is that there's a lot of mathematics that goes into statistics. And the truth is that we can be extremely, extremely accurate. Now, keep in mind, people's opinions change. They wildly fluctuate over time. There's a very famous example from like 60, 70 years ago. I don't remember the actual names of the people who were going for president, but some magazine came out and said that so-and-so was certain to win because 80% of the people or whatever number it was were going to vote for him. Just a crazy amount. And he ended up losing. And this was like, how's that possible? I mean, our sample showed that he was going to win. This is crazy. And it turned out that their sample came from subscribers of their magazine. And the subscribers of their magazine tended to be of a certain party, political party. And people in that political party, of course, are more likely to vote for that party's applicant. So it was not a representative sample of the entire population. And this was like a all across America survey. This was like a big thing. I just forget the names. I think it might have been Dewey and Roosevelt, maybe. I don't remember. But anyway, another example of a bad survey is the following. Who here likes sports? You could just say me. I got one person saying me. Okay, one person in the class likes sports. Okay, we got a few people like sports. I myself was quite the athlete back in the day. I know you look at me now and you're like, what? But back then I was quite athletic. I was tri-varsity in high school. And then I was a kickboxer in my 20s. Football, baseball, basketball. I did all three. And then I was a kickboxer in my 20s. And then I began playing tennis. And now I'm on a few teams. I play tennis, or I did before the pandemic. And then I had a 5-year gap where I played golf. So I've been playing. Oh, here's a build. Yeah, look at those shoulders and arms. That's what I'm talking about. Yeah, buddy. Anyways, so now of course I'm fat. But back then I don't do UFC. I do boxing. No UFC. UFC is not my thing, but boxing that's my thing. Anyway, back on track. So suppose I'm interested, Jones or Tyson. Well, I always got to go with Tyson against pretty much anyone, even though I think that Roy Jones Jr. is the greatest pound-for-pound fighter of all time. That's just me. Anyway, back on. I don't know, for those boxing fans out there, just for a second. I don't know if you guys know Joe Calzaghe. He was always one of my favorites when I was fighting. And, Floyd Mayweather, of course, in my opinion, is just the greatest. But anywho, back on track now. So I'm interested in knowing what people's favorite sport is. So I decided to go to a Lakers game. And when I'm at the Lakers game, I ask everyone, hey, what's your favorite sport? Hey, you, what's your favorite sport? Hey, you, what's your favorite sport? And so on. Do you think that I'm going to get a sample from that's a representative of the entire population? No, it seems patently obvious that people in that sample are probably going to be more inclined to like, exactly, it's biased, right? People at a basketball game probably have an inherent bias towards liking basketball. And because of that, you know, it's not really that representative of the entire population. So when it comes to sampling, there's ways of sampling well, there's ways of sampling poorly. We're not going to go really deeply into it, but just be aware that there are courses that you can take just on sampling. Not in CSUN, but in general. There are probably dissertations that have been written for PhDs just on sampling. It's a huge and an important part of statistics, because at the end of the day, you can't ask everyone what their opinion is, so you ask a sample. And what do? We take that sample and we try to extrapolate from that sample to the entire population. And we say, well, my sample was, you know, 60% this, so I'm going to extrapolate and say that the population is probably around 60% that. But you can only do that if it was sampled correctly. So this chapter is about how you go about sampling. It's very qualitative. There's no math in this chapter, or very little math in this chapter, very qualitative. And we start off with the difference between, of course, the population and the sample. So the population in a statistical study is the entire group of individuals about which we want information. In the case of politics, it's every person of voting age who is legally allowed to vote in America. We want to know, I don't care about a 7-year-old what their opinion is, okay, because they can't vote. What do I care what they like? Even a 15 or a 16-year-old can't vote. What do I care what they like? It's the ones that can vote. That's the population under consideration. You don't ask everyone. You don't have the time for it. But instead, you take a sample. A sample is a part of the population from which we actually collect information. Now, if I ask everyone in this class what they're going to vote for, some people will say, I'm going to vote for Trump. Some people will say, I'll vote for Biden. Some people will say, I'm not going to answer. It's a personal opinion. That's none of your business, and that's perfectly fine. The point is that the people who don't answer are not part of my sample. I don't have any information from you. The sample is a part of the population from which I actually collect information. So those who answer, I can use that as my sample. Now, the method by which I sample, there's many different ways you can sample. It's called a sampling design. The sampling design is the method by which you can get your sample. Okay, a sampling design describes exactly how to choose a sample from the population. And in this chapter, we're going to learn, I think 4, maybe 5 different methods by which you can take a sample. Okay, but that's what's called the sampling design. Make sense so far? Any questions? Yes, no, maybe so. Everything good? Makes sense so far. Okay. So let's see what it says here. It says choosing a representative sample from a large and varied population is not so easy. The first step in planning a sample survey is to say exactly what population we want to describe, then what we want to measure. So these are all things that you can read about in the chapter. I hope you do. I want to focus on the main things of the chapter to give you the overview, and then you can go into the details yourself by reading it and by doing the homework. So let's start by how to sample badly. Okay, these are the types of samples that you do not want to do. The first one is called a convenience sample. Okay, you sample in a way that is convenient. For example, a sample of mall shoppers is fast and cheap. Go to the mall, at least before the pandemic. You go to the mall and there's people walking by you left and right, correct? Okay, hey you, what do you think? Hey you, what do you think? Hey you, what do you think? They're mostly likely to be teenagers or retired. You know, kids go to the mall, maybe not anymore, but back in my day, that's where everyone hung out. And people who retire, what else are they going to do? So they go to the mall, they walk around, they do their, you know, their power walking classes and nonsense. Okay, so essentially, you're at the mall, you're there. Your sample is probably not representative itself because it only targets a certain portion of the population and not everyone. And 2, who are you going to stop? Who are you going to ask? Hey, you, what do you think? You ask people that maybe when you look at them, you get the feeling that they'd be inclined to answer. Oh, that guy with this, you know, he's walking fast. He's got a stern. I'm not going to bother him. Oh, but that one, he's just walking around and doing this. Hey, how you doing? So it's convenient because everyone is there, but it's not representative. We call that a convenience sample. Very likely to be biased. Okay, a biased sample in general favors certain outcomes over others inherently. Okay, so the basketball example, that was a biased sample because people who go to a basketball game probably are going to like basketball. Okay. The other type of bad response or bad sample is called a voluntary response sample. A voluntary response sample is people who choose to respond on their own. What's an example of voluntary response sample? You're on the internet, you're browsing, you go to a web page devoted to something that you like, and there's a poll. Who's your favorite character in Game of Thrones? Who's your favorite this? Who do you hate most here? Which couple is the best? And all these different questions. Now, when I come across those things, I skip them. I don't got time for that nonsense. Why do I skip them? Because I don't care about them. Right? Right? I don't care about them, so I don't bother. Who are the type of people who would care about those types of things? People who are very invested in it one way or the other, right? I'm looking for any response here. I have nothing. I don't see anyone because I'm sharing my own screen and I don't have any yes or no. So I need something, guys. I need some give or take. Not, boxing give or take, but just, something that I know you're out there. Excuse me. So the two bad types of samples are convenience samples and voluntary response samples. Okay, we don't want voluntary response because it's only going to be from people who are probably very strongly invested in the subject, and convenience samples are very likely to miss a significant portion of the population that I might care about. The best type of sample is an SRS, a simple random sample. These are the samples for which most of the formulas in the class are going to be based upon. So quite often we're going to assume that you have an SRS, and then it'll go on. And because it has an SRS, a simple random sample as your sampling design, then all these formulas that we've derived are all going to be appropriate for the class. And if you don't have an SRS, you usually can't say that. Now, we're not going to prove or show why an SRS is so important, but we are going to describe exactly what an SRS is. So imagine rather than having this internet class, we were actually all in a classroom, and I had 40 students in the classroom all over the place, a big CSUN classroom. And suppose you were teaching for a second, and you as a teacher, we're going to pick 5 people at random from the class. So one way of picking 5 people at random from the class would be to have everyone put their name in a hat, and you shake the hat around, and you reach in and you pull out 4 slips of paper or 5, whatever I said, and you read it off. And that's perfectly valid. That, by the way, is what an SRS is, as I'll explain in a second. But let's say you feel like you don't have time for that. Let's say you're like, you know what, I just want to pick 4 people at random. Tell me what you would do practically. Give me something that you might do practically to pick 4 people from the class that you feel would be at random.
If there's 40 people in the class, then every 10th person.
Okay, so every 10th person, but what do you mean by every 10th person? Does that mean by alphabet? Like by alphabetical order? By seat? What do you mean?
Doesn't matter, right?
Well,
if it's random, it's better.
Well, if it's every 10th person, is there any randomness to that?
No.
No, there's no randomness if it's every 10th person, right? In fact, that's just the opposite of random. That's very systematic, right? Randomness is, it could be anything. But if it's every 10th person, then that's very systematic, correct? Does that make sense?
Yes.
Now, someone else said random number generator, and that's perfectly valid. Let's say you don't have one at hand. Let's say you just don't happen to have a random number generator at hand. What are some other possibilities?
Can you just close your eyes and just pick 4 people?
Okay, close your eyes and get 4 people. So how do you do that? You just point randomly?
Yeah.
Is that what you're going to be doing?
Yes.
Okay. If you did it that way, you'd probably say 1, 2, 3, 4, right? You'd pick randomly at 4 different spots in the room, correct?
Yes.
Okay, now, is that really random then when you don't include the possibility of getting 2 people who are right next to each other? Yes? Does that make sense what I'm saying?
Kind of. Well, because they could have sat there next to that person, but they also couldn't have. It's just random where they decided to sit that day, right?
That is true. But for this day in particular, there's no possibility by that approach that you're going to have 2 people that are right next to each other, or even 3, or all 4. Right? The human mind naturally thinks randomness means different areas.
I see.
But if it's truly random, then really any 4 people are possible to have been picked, including 4 that are right next to each other. Right? If you did it out of a hat, is it possible that 4 next to each other would have been hit?
Yes.
Yes, right? So, but if you're doing it like this, then there's no possibility that can occur, because humanly, we just don't see that as being random. We think random means in 4 different situations, right?
Yeah.
I've got an idea.
Okay, so a simple random sample, and someone said there's no such thing as true randomness. Well, we approximate it as best as we can, right? As best as we can, true randomness is what an RNG would provide, a random number generator, which we'll look at in a second if you're not familiar with that. But let me explain what a simple random sample is. A simple random sample is a situation. So let's say I have 40 people and I want to pick 5 of them. If it was truly a simple random sample, any of those 5 people would be as equally likely to be chosen as any other 5. So 1 there, 1 there, 1 there, 1 there, and 1 there is just as likely as all 5 in the same row. Because if I pick them out of a hat, those 5 spread out, or those 5 together, are just as likely to be chosen because it's just one of the 5, one of the possible options.
But Professor, if it was a repeat, wouldn't the chance be less?
What do you mean a repeat?
Like, for instance, when you're flipping a coin and the possibility of getting 2 heads compared to 1 head, like say you want to choose the same person, right? We're choosing random samples of people in the room and we choose the same person twice. The possibility or the probability of choosing the same person but the second time in a row would be less than the probability of him just the first time.
So we're not talking about probabilities here. Okay, we're not talking about likelihoods.
But didn't you say it's the same likelihood for everyone to be picked?
Well, okay, let me rephrase that because that's a good point. My phrasing might have been incorrect. So first, how is it possible if I pick 5 people at random by picking their names out of a hat that I would pick the same person twice? Would I put it back in the hat afterwards? Why am I doing that if I want 5 different people?
Well, I was just kind of taking it from the example you were talking about before, where if we were to close our eyes and, like, for instance, 4 different areas, I remember you said something about picking either someone sitting right next to them or the same spot or whichever. But if we're assuming that we're canceling them out after picking them, then yeah, it wouldn't even matter.
Exactly. So that's the case here, right? When I do this and I pick someone, they are no longer part of the consideration. They have already been chosen.
Oh, okay.
And therefore they're now gone. Okay. So in that case, if I do 1, 2, 3, 4, I'm not literally picking the same person 4 times. I'm just picking one person who's now gone, the person behind him is now gone, person behind her who's now gone, and so on, whatever the case may be. Okay. But the point here is that, well, think of it like this. Let's say there's 3 people. 3 people, and I want to pick one of them. How many ways can I pick one person from 3? Right, there's 3 people in front of me, and I want to pick one of them. How many ways can I pick one person from the 3?
Name in the hat.
Well, no, I'm saying not how would I do it, but how many ways. I'm looking for a number. how many ways can I pick one person from 3?
Nine.
What are the
Oh,
9 ways? There's, let's say person A, person B, and person C are in front of me, and I want to pick one of them.
Oh, just one. Okay.
All right, I want to pick one person from the 3 that are in front of me.
So isn't there 3 different ways?
Yeah, I can either end up with A or B or C. Right? There's 3 different ways, right? I can either end up with A or B or C, correct? Does that make sense? I don't feel like I'm being clear here. If there's 3 people in front of you and you want to pick one person from those 3, you could either end up with person A or person B or person C. There's no other way to end up with one person from those 3. Would you agree? I need something here, people. I need a verbal or
Yes.
typing. I need some people. I need to know that either people are or are not understanding. Okay, it's very. I don't see anyone right now because of sharing the screen. So I really need to see words or hear them, please. Okay, so if there's 3 people in front of me, then and I want to pick one of them. There's 3 ways, either A or B or C. Now, let's say I want to pick 2 of them. How many ways are there of picking 2 people from 3?
Two.
Okay, what are the 2? Tell me what the 2 are. There's A, B, and C in front of me. I want to pick 2 of them. How many ways can I do that? Tell me what those 2 ways are.
I guess either A to C or A to B or C to. Actually, I don't know.
Okay. So I can end up with person A and person B. That's one possibility. What's another possibility besides person A and person B?
Oh, so then would it be more
B
than
and
2?
C.
Okay, so Stephen got it, right? It can either be A and B, B and C, or A and C. 3 ways of picking 2 people from 3. Do we agree?
Yes.
Okay, now, of course, if it was 100 people and I want to pick 20, then the number of ways will, numerically, the number of ways, of course, is going to be very, very large, right? Correct? So
Yeah.
we're not getting into the mathematics yet of how to count how many ways there are. That's not what we're doing right now. We're just talking about how many, we're just talking about more in general of those ways, in this case, 3 ways of taking 2 people from 3. Are all of those 3 ways possible? So for example, let's say A and C hated each other and refused to work together. Then I could not pick A and C because that's not a tenable combination, right? And I'd only have A and B and C, right? Yes?
Yes.
So this would not be a simple random sample because not every possible combination of 2 people from 3 is as likely as any other. In this case, only 2 of them are possible and 1 of them is not. Okay, so that would not be a simple random sample because I cannot get every possible combination of 2 from the 3. A simple random sample requires that every possible way of getting n from the population is as likely as any other. That is by definition what a simple random sample is. Okay? It is the most important type of sampling design because it is as random as it gets. Anything else is less random than this one is.
Can you give an example of a simple random sample? Like, I know we did it.
Sure.
Like, what not, but can you give like a set example of what it is?
Sure. So let's say I'm teaching the class and I want 2 people in the class to go pick up something and bring it to me because it's heavy. So I need to pick 2 people. Now, I could pick the 2 best in the class. I could pick the 2 worst in the class. I could pick whatever I want, but I decide to do it fair, I put everyone's name in a hat and I pick 2 at random. Do you agree that any 2 people in the class are just as likely to be chosen as any other 2 people in the class?
Yes.
Then that makes it a simple random sample. But if I say, okay, I want 1 boy and 1 girl, or if I say I want 1 good student and 1 bad student, or I say I want 1 this and 1 that, whatever the case may be, then I'm no longer considering the possibility that any 2 people are as equally likely as any other 2. For
But
example,
if there were an equal amount of boys to girls and same with equal amount of good students to bad students, then it would be the same likelihood?
no, because is it possible that I can pick 2 boys?
Oh, yeah. Okay.
Right? So it's not possible that any 2 people are likely to be chosen as any other 2. 2 boys will never happen. 2 good students will never happen, or whatever I decide, right? So a simple random sample requires that any group is just as likely to be chosen as any other group. That is, by definition, a simple random sample. And the only ways to get one, other than the very artificial picking a name from a hat, is really with a random number generator. Okay, you assign a number to each person, 1 to 50. You tell your computer to spit out 2 numbers. Is it going to do 1 and 2? Maybe. Is it going to do 17 and 41? Maybe. Is it going to do 19 and 26? Maybe. Any 2 numbers are possible, next to each other, far apart, in the middle, doesn't make a difference. Any 2 are likely as any other 2. We have a simple random sample. If I divide the group up into pieces and say 1 from this piece, 1 from this piece, it's no longer simple random because 2 from the same piece will never happen.
Professor, you said, like a few seconds ago, you said there's no way the 2 best students would be chosen together.
What I meant by that was if I want to pick people so that I pick 1 good student and 1 bad student, then 2 good students will never be chosen because I'm not allowing that possibility.
Okay, thank you.
Right? Just like if I chose to do it by boys and girls, males and females, then 2 males or 2 females would never happen because I'm not allowing that possibility. By choice, by arbitrary choice. Does that make sense?
Yes, thank you.
Okay. So a simple random sample is the best, but it's not always the most appropriate. Sometimes other things are more appropriate. For example, how many people does each state send to the Senate?
2.
2, straight across the board, right? But is it also 2 for the House of Representatives?
No.
Is it the same amount of people from each state for the House of Representatives?
No.
No. It goes by what?
Population size.
It goes by population size. So sometimes, if I had to pick 100 people at random from America for a survey, then you might say, okay, I want 2 from each state so that it's representative of the entire country. But if I do 2 from each state, is that a simple random sample?
No, because the populations are different in each state.
But that's not the reason why it's not a simple random sample. That might be why it's not a good sampling design. But if I want 100 people from America and I choose to take 2 from each state, why is that not a simple random sample?
Because you don't consider the possibility of 4 people from the same state being selected.
Exactly. You don't consider the possibility of any people being chosen in a group of 100. Okay, it's impossible for 4 in the same state to be chosen because I'm limiting it to 2 per state. So that's why it's not a simple random sample. Is it a good sampling design? Maybe not, because I want states with more people to have a higher representation. So in that case, I might not do a simple random sample. I might do a different kind of sample. But the point is, it's only simple random if in any size group, let's say 100, any 100 people are as equally likely to be chosen as any other 100. So I could theoretically end up with 100 people from California. That's a theoretical possibility because we're all in California, the 50 of us who are in this room right now, and then 50 more people down the hall, that's 100. That's a possibility, and it's equally likely as any other possibility. That's what a simple random sample is. And
Wait,
a random,
Professor,
yeah, go ahead.
I'm sorry. Can
No,
you just
please.
explain? Can you just explain why it won't be why the SRS isn't appropriate for the 100 people and the 2 from each state again? Because it's not considering what again?
Well, that's more of a sociological factor, that if I really want to have a survey of some kind, which is representative of all America, then I might want to have more people chosen from California than from, let's say, Nebraska, because there's significantly more people in California than Nebraska. Do I really want to have 2 from each? And do I want the 2 in Nebraska to have an equal say to the 2 in California when I'm looking for a kind of like to have an idea of what the country feels about something? Okay, the 2 from California is 2 from 20 million, whatever it is. The 2 from Nebraska is like 2 from 17, or however many people live in Nebraska. I don't know. But because the populations are so different, then you can think that I want the size of my survey from each state to be proportional to the population size. But that's a sociological thing, not necessarily a statistical thing. I'm just giving an example of a possibility where the same number from each state might not be appropriate. Does that make sense? Or still not? If the answer is no, that's fine. I can try again. I'm just asking.
No, I just want you to, because I think someone said it like on, then you continue. He said something about like, oh, because it's not considering something, and then I just forgot.
Oh no, the reason why it's not an SRS is because if you take 2 from each state, you're not considering the possibility that there could be a different number from each state chosen. You're limiting it to 2 from each state, which means you and me and someone else in this class will never be chosen in that survey, ever. Because if you're limiting it to 2 from California, how can you have 3 from California chosen? It's not allowed. But if it's a simple random sample, any people should be allowed to be chosen. Yes? No?
So for instance, in the same way how we were talking about choosing 3 random people, let's say like we're in a classroom of 50 and you choose 3 random kids to come up to the front and you're trying to do a simple random sample on those 3 kids and the equal likelihood of getting it from those 3 only. It wouldn't be simple because even though there's 3 kids, you're setting a limit because there's 50 kids in the whole class total, right?
Wait 1 second. So there's 50 people in the class and I'm going to pick 3 of them, right?
Yeah, but instead of picking 3, you take 3 kids from the class, bring them down to the front, and you're trying to figure out the likelihood of picking them in a specific order, right?
Well, what was that? You're hold on. Nothing about order here.
Okay.
We're not doing anything about order. Okay. If I want 3 people from a class of 50, and I choose 3 people to come to the board, that's one possible choice of 3 people, right?
Oh, let me rephrase it.
Okay.
So say it's 100 kids in a class, right?
Okay.
And you're limiting it to, you're trying to choose 3 of 50 out of the 100. So like say you're dividing the classroom in half. So you want to take.
So I have the 50 on the left and the 50 on the right.
So you want to choose 3 from the left side. That wouldn't be simple because there's still a right side.
That's correct.
Okay, got it.
That's correct. Yeah, there's no chance that I would end up with 3 people or any people on the right. And therefore, 3 people on the right is not as likely as 3 people on the left. And because any 3 are not as likely as any other 3, that would not be a simple random sample. I don't feel like everyone's getting this, but we have to move on. So yeah, we have to move on. A simple random sample, again, let's just read the box. So first of all, it's of some size. You got to pick a certain number of people. In this case, we're picking n. It consists of n individuals from the population chosen in such a way that every set of n individuals is as equally likely to be chosen as any other. So if your sampling design does not allow that possibility, then your sampling design is not a simple random sample. Let's just leave it at that, okay? And hopefully that makes sense at this point. And if not, think about it, look it over. But we do have to move forward. I have to make sure we finish this today. Normally I don't like doing that, but the test is next week, so we do have to finish this. So now, inferences about the population. Okay, what is the purpose of taking a simple random sample or any sample? The purpose of a sample is to make some kind of inference about the entire population. Okay, my sample said that 70% of the population is going to do this. Can I conclude that 70% of the population actually will do that? Can I infer from the population from my sample? So the rest of this course from here on out is going to be focused on inferences of the sample to the population, when you're allowed to, when you're not allowed to, and how accurate those inferences are. But this is why we take samples. We take samples so that we can infer something about the population. That's the purpose of them. Otherwise, why take a sample? What do I care what the people in our class are going to vote for? Does that by itself tell me anything about the actual outcome for the election across the entire country? We have what, 40 people in the class? Let's say we all vote. Let's say we all vote the same way. That tells me nothing. It tells me nothing about what everyone else in the country is going to do. But if I can somehow infer from my class sample about the population, now I can start thinking, okay, wait a second. This might insinuate something about the entire population, and that at the end of the day is the goal. Okay, so 8.5, let's talk about other sampling designs. Let's actually, before we get to this section, let's just take a 5-minute break. If you still are having questions on simple random samples, stick around. Let's talk about it a little more. I teach a lot on Tuesdays and Thursdays. So by this time of night, my throat hurts a lot. I mean, hey, it's, you know, what can I do? But thank you for asking. But let's take a 5-minute break. And if you still have a question on sampling, simple random samples, let's talk about it. So I'm just gonna.
Yes.
Yeah.
So going back to the 100 people from America and you want 2 from each state.
Yeah.
It's not for us because since you're only taking 2 from each state,
yeah,
you are taking away the possibility that there is more, like there can be more people from that state.
Sorry.
No, you're okay.
Say that again, please.
So since you're only taking 2 people from each state,
yeah,
it's not for us because you're taking away the possibility that other people can join in the survey.
Well, so let's take a step back. Let's say I want 100 people chosen from America. Not necessarily for politics, just in general. I want to pick 100 people from America. And how many people are in America? What, like 400 million people? Something like that, whatever it is, some huge asinine number, right?
Yeah.
And I want to pick only 100 of them. So there's lots of ways. There's lots of ways that 100 could be picked. I could end up with 100 people from New York, or 100 from California, or 2 from each state, or 7 from there, 3 from there, 2 from there, none from there, and so on, right? These are all possibilities, correct?
Yeah.
And any one of them is possible. I mean, any one of them is, it's an outcome, right? These are all outcomes, right? But if I said in advance, I only am allowing 2 people from each state. If I say that, then I am now removing a significant number of possibilities, correct? For example, is 100 from California now possible?
Oh, can you repeat that again? Sorry, you froze.
If I say that
From like the since
Yeah, can you hear me?
Yeah.
If I say that I'm only allowing 2 people from each state, if I say I want 2 people from each state, are all of those original possibilities still possible?
No.
No, I am removing a significant number of them. But for it to be an SRS, every possible combination has to be there.
Oh, okay.
Okay, that's the key. Any possible combination has to be there for it to be an SRS.
Got it. All right. So you're basically, it's not SRS because you're limiting the data, the sample size, the data.
Correct.
Okay.
I'm limiting not so much the data, but the possibilities for the data more than anything else. Yes, no, maybe so?
Thank you. No,
Okay.
no, that's perfect. Thank
Okay. Okay. What is our plan for next week? Still chapter 8. So the plan for next, so 8 is very small. We're going to finish it. It's not really big. It's very conceptual, not really mathematical. But we're going to finish 8. The test next week will be on 1 through 5 and 8. Oh, I didn't post homework 5 yet? Okay, let me do that now. So Launchpad. Okay, so well, I'll do it after class tonight, but yeah, I'll post 5 and 8 tonight. And they'll be due next Thursday. You'll have a week. And yeah, so and then next week we move on. Even though the test is not till next weekend, we're still going to move on. Still got things to do. And so sorry.
Professor, do you still watch boxing?
You know, I really don't have anyone that I like watching anymore. It's just some lemon tea. I should. I just I'm just so busy these days. I don't really watch anything. But why is there a fight coming up or something that's worth watching?
I mean, other than the Tyson fight, I think they confirmed Mayweather to come back and fight one more fight against some stupid ass YouTuber. But like that's a joke. But I was gonna say, like, I was gonna ask you if you were a fan of Triple G.
You know, I am. I like him. He seems like a nice guy. I wasn't. You know, after Mayweather destroyed Alvarez, which was totally expected anyway, and then Alvarez was pretty much equal to Triple G. I mean, you know, it's arguable who should have won each of the fights, but they were very close to each other.
I think it was arguable with the match between Canelo and Triple G.
Yeah, that's what I'm saying. That's what I'm saying. They were very, very arguable who should have won. So they're very similar fighters, very close. And after Mayweather just destroyed one, why wouldn't he destroy the other if they would have fought, you know, a few years back? After that happened, it's kind of like, just another power puncher. Do you know who Joe Calzaghe is?
No, I'm not too familiar with him.
So see if you can find the fight between Joe Calzaghe and Jeff Lacey. Okay, on YouTube or something, or see if you can find it. Calzaghe versus Lacey. Lacey was like the next Mike Tyson, just huge power puncher. And he came in and he was supposed to just utterly destroy Calzaghe. And he just put on a clinic. He just destroyed him. I mean, and didn't knock him down or anything. Calzaghe was never a power puncher, but just I mean, Lacey pretty much quit after that because of how bad he was in comparison. You know, when you have these amazing fighters, they make other people who you think look good, they reveal all their weaknesses.
Yeah.
And I think if Mayweather would have fought Triple G, it would have been the same thing. He just would have, shown that he was, he wasn't all that to begin with.
What do you think of Lomachenko?
Which one?
Lomachenko.
So he's one of the newer guys. I'm not really familiar with so much with him. I mean, I know the name, but I haven't really watched boxing in a few years, so I really don't keep up with all of them.
Do you think Tyson in his prime would take Mayweather in his prime?
Yeah, they're different. Tyson was twice as big.
I mean, they met in the middle, though. I'm just saying skill-wise.
Skill-wise? No. First of all, Tyson had some great skills.
Yeah.
He wasn't just a power puncher. I mean, he moved. I mean, he was, he knew how to move.
Even now.
Even now. Yeah, you see that video of him hitting the bags?
Easy.
I'm telling you, man. I haven't fought in like 15 years, and I know what it's like to lose some of that stuff. And my God, I mean, I was scared just watching it. I mean, that was just. I mean, I don't know what Roy Jones Jr. is thinking. Roy Jones Jr. fought at super middleweight, light heavyweight, and I mean, weight classes are there for a reason. That's all I can say. I mean, you go up against a guy who's that big. I'm.
And then there's Anthony.
Huh?
There's, Andy Ruiz versus Anthony Joshua 3 coming up too. It's gonna happen.
Yeah.
That when Andy Ruiz took that first fight, that shocked me. Like.
Yeah, it was. There's very few fight. I was always more of a technical fighter. I wasn't. I was big for my size. I mean, I'm fat now, but I'm saying even as a fighter, I was never a heavyweight. I was I fought at 175, so I was pretty strong. But I always admired the defensive fighters more. I always just think it's it's one thing to be strong and to take a punch and just get in there and hit, and it's another thing to avoid punches and just to counter punch and everything. I think it's wonderful. Anyways, we're over time. I got to go back to class. So let's go back. Let me share screen again. And here we are. What did someone just say? Someone just said something. What was that? I missed that. It was which slide? What slide? So let's find it. It's not really a slide so much. It's the page. So we're on section 8.5 now. And section 8.5 is on section 8.5 is on other types of sampling designs. Okay, we know that a volunteer sample is bad. We know that a convenience sample is bad, and we know that an SRS is good. There are other ones that are not quite SRSs, but are good in their own right. And the first one is called a stratified random sample. And a stratified random sample I actually alluded to earlier. This is when you first break up the entire population into groups called strata, where they have some kind of similar characteristic. And then you pick an SRS from each one. So for example, the most obvious would be from states. You can break up the entire population into states and then pick an SRS from each state. And in that case, you might say, well, I want more from this state or from that state, which is totally fine. Nothing says they have to be the same size. But this way, the SRS is still there. It's just within the group. So California, let's make an SRS. And Oregon, let's make an SRS. And Washington, let's make an SRS. So you break it up into groups, and then you do an SRS from each group. There's something similar to this called a cluster random sample, which the book doesn't talk about. A cluster random sample, which starts off the same way. You break up the population into groups. The difference is you just take some of the groups. So I might take everyone from California and everyone from New York and everyone from here. And that'll be a cluster random sample versus a stratified random sample. Again, stratified groups, a little bit of each group, SRS from each group. Cluster is groups again, but you'll take some of the clusters in their entirety. So that's called a stratified random sample. Again, 8.6, cautions about sample surveys. What are some things to worry about when you do sample surveys? So there's two basic things to worry about: under coverage and non-response. Under coverage is when you don't get a representation of the entire population because you're missing some portion of it. So for example, let's say I just don't get anyone from California, or I don't get anyone who's a teenager, or I don't get anyone who's this, or I don't get anyone who's that. Those are all underrepresentations because you're missing covering a certain percentage of the population, called undercoverage, something that you want to be on the lookout for. The other one is called non-response. So non-response is when you have a wonderful sample and you think everything's going to be great about this sample, but you can't contact them or they refuse to participate. What's an example of a situation when people fail to refuse to participate in a sample? That's something like when you call them, a telemarketer, right? Or at the end of you ever call like a bank or something like that, and they go, please stay on the line when we're done so that we can, take a survey about yada, yada, yada. And you're like, I don't got time for that shit. I'm not staying on the line, right? So that's non-response. You're not responding even though they're counting on you to. So under coverage and non-response, those are the two things you should be concerned about when taking sample surveys. And of course, there's the wording, okay? The wording of a survey. For example, suppose I ask you the question, I like this one here. How happy are you with your life in general? Answer on a scale of 1 to 5. Okay, so suppose I said, how happy are you in general? Answer on a scale from 1 to 5. And you're like, well, life is good. I got my health. I got a job now, and I just bought a car, and this and that, and you're like, hey, this is great, right? Everything's wonderful. And then I ask you, how many dates did you have last month? And you're like, yeah, I didn't have any dates last month. Oh yeah, life sucks. Well, but you already answered how happy you are with life in general, so you can't go back on that. But if I would have changed the order and first asked you, how happy are you with life in general? First asked you, how many days did you have last month? And you go, none. And you go, how happy are you with life in general? And you're like, well, life sucks. I didn't have any dates. Even the order that you ask could have an effect on the answers, right? And that's just the order. What about the wording? I can say, like, how do Americans feel about illegal immigrants? Should illegal immigrants be prosecuted and deported for being in the United States illegally, or shouldn't they? So asked in this question in an opinion poll, 69% favored deportation. But when asked the very same sample about illegal immigrants who have worked in the US for 2 years, should they be given a chance to keep their jobs and eventually apply for legal status? The same sample, 52% said they should. So how was that possible? The 70% or so said get out, and 60% said, well, give them a chance. It's the same sample, but different wordings, and all of a sudden their answers are completely different. Sorry, Professor, I lost connection for a few minutes. Well, welcome back. So different questions can give different impressions of attitudes toward illegal immigrants, like we have here. And just be on the lookout, again, very qualitative, that the wording can have a significant effect on the response. Okay, these are all things that a person taking a course in sampling design would go over, and we're not going to do that. So for us, it's just conceptually. If you understand conceptually what we're talking about, that's good enough. So are there any questions on anything that we went over so far today? This is just very conceptual chapter, not mathematical at all.
Could you go back to what you said? Oh, there, no, non-respond.
No, sorry.
To here?
Yeah.
Sure. Am I saying something, or you're just reading it? I forgot what's going on.
Oh no, I was just copying down.
Yeah,
With
okay.
not. Okay. So I'm good now.
Does someone have a?
Can you explain the difference between strata and cluster again?
Yes. So in both strata and cluster, in both cases, you are breaking the population into groups. Maybe you're doing it by states. Maybe you're doing it by gender. Maybe you're doing it by age. Maybe you're doing it by nationality or race or whatever you decide. But you're taking your population and you're dividing it up into pieces. Now, for a stratified sample, you take a little bit of each piece. For a cluster sample, you take a few pieces. So if I divide into 10 pieces and I take 2 from each piece, that's stratified. But if I divide it into 10 pieces and take 2 pieces in their entirety, that's cluster. Does that make sense?
So strata takes a piece from each group, whereas cluster takes a few pieces from the whole thing.
So it's like, I mean, yeah, but let me just clarify that. So suppose there's 100 people in a population, or 100 objects in a population, and you divide that population into 10 different groups of 10 items each. Okay, so let's see if I can annotate this. See if I can make it a little more clear. So you have 100 items in total. And what you do is you break it into, just because these circles take a long time to make, 5 pieces of 20 each. So there's 20 in here, and 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 there's 20 in here. A stratified sample says take some from here, some from here, some from here, some from here, some from here. Take a little bit from each piece. A cluster sample says just take those pieces. So I take some of the pieces in their entirety versus a little bit from each piece. This is a cluster. I'm taking the entire pieces. That's a cluster sample. If I take a little bit from each one, that is a stratified sample.
So then the cluster would just take the whole group.
the cluster would take the entire, exactly, they would take the entire group. Whereas stratified takes a little bit from each one.
Would you still take the SRS in a cluster?
Well, not for a cluster, because for a cluster, you're taking the whole thing. So you don't got to take an SRS. But for the stratified, yes, you're taking an SRS from each one. Yes, no, maybe so. Right? There's no SRS here because you're taking the whole thing. So what random sample is there? You're just taking the entire object. Now I might pick these two at random. I might say, okay, there's 5 of them. Let's pick these 2 at random. I can use an SRS for that, as opposed to the SRS inside each piece, which is in the stratified. So stratified gets inside and cluster stays outside. I guess you could think of it that way. Does that make sense? Maybe a little more sense?
Yes, thank you.
Okay, so I will put up homeworks 5 and 8 tonight, and you'll have a week for them. And I'm going to stop sharing, and I'm going to stop recording.